Hello everyone, here is a question based on mole concept. What mass of 95% pure calcium carbonate will be required to neutralize 50 milliliter of 0.5 molar HCl solution according to the following reaction. The reaction is already balanced. The stoichiometric coefficients for CaCO3 and HCl are 1 and 2. Finding the right answer for this question is a 4-step process. First, we need to find the number of moles of HCl based on the volume and molarity of HCl given. Second, we need to find the number of moles of CaCO3, which we can do it through stoichiometric moles. And third, we need to find the mass, that is weight of CaCO3. However, the weight that we find will be 100% pure, and therefore we need to convert that into 95% purity. So, this is a 4-step process and we will do it one by one. For HCl, what is the information given? Volume is 50 milliliter, molarity is 0.5 molar. We know that number of moles is equal to molarity times volume in liter. Let us convert the 50 ml into liters, and therefore 1 liter times 50 ml divided by 1000 milliliter. Milliliter will cancel, 1010 will cancel, 5 and this will be 20, and therefore 50 ml is equal to 1 by 20 in liter, that is our volume. Now, N is equal to 0.5 mole per liter times 1 by 20 liter. Liter per liter cancel. So, this is basically 1 by 40 because we have 1 by 2 here. So, 1 by 40 moles, and therefore, N is equal to 1 by 40 is 0.025 moles. So, that is for HCl we found. Now, how do we write stoichiometric moles here? Stoichiometric moles, we can write that one by one, whatever is the coefficient that you have here, that we bring it in the denominator. Number of moles of CaCO3, and here we have 2 as the coefficient, and therefore 1 by 2 number of moles of HCl. These two we need to equate, and therefore number of moles of CaCO3 will be equal to 1 by 2 times number of moles of HCl. Number of moles of HCl we found was 0.025, and therefore number of moles of CaCO3 will be 0.0125 moles. That is the amount we will get. From the answer that we get in step 2, we can find the mass, that is weight, because number of moles of CaCO3 is equal to mass of CaCO3 divided by molar mass of CaCO3. What is the molar mass of CaCO3? For calcium 40, for carbon 12, and then we have 3 oxygen atoms. So, 3 times 16, that is 48, and therefore this is 100 gram per mole. Therefore, the mass of CaCO3 is equal to number of moles of CaCO3 that we got is 0.0125 mole times 100 gram per mole. Mole per mole cancel, and therefore this is 1.25 gram. Therefore, the mass of CaCO3 is 1.25 gram, but this is 100% purity. Now, we need to find it for 95% purity because 5% impurity is there. Let us do step 4. 95% means what? 95 divided by 100. So, we do not know the weight. So, let us keep that as x. 95 divided by 100 equal to 1.25 gram, and therefore, x is equal to 1.25 times 100 divided by 95, and therefore, this is equal to 125 divided by 95. This will be 25, this will be 19. If we equate this to the second decimal place, then this is 1.32 gram. Therefore, X is 1.32 gram. That's the correct answer. Therefore, option 3 is correct.